everyone, myself Asha from Sri Ramakrishna Engineering College. So our project is bidirectional visitor counter. So we monitors the person when they are entering into the room, or it also monitors when the person leaves the room. We are using two IR sensors. So one is used for counting the people which are entering the place, and another one for person who are leaving the place. So we'll be using Arduino microcontroller for this project.
A project can be implemented for various applications like in parking slots in malls and in hotels and also in theaters.
Now we will be seeing about the entire project construction step by step. Now let me explain you the intro of our project and the components used. The bidirectional visitor counter is a compact system that keeps track of how many people are present inside a room just by monitoring the entries and exits. It operates using a simple logic, that is just by counting them when they enter and then subtracting when they leave. This logic helps maintain an accurate real-time count displayed clearly on the LCD screen. The core of this project consists of just two infrared sensors installed side by side at an entrance of a room. These sensors detect a person crossing the doorway, but more importantly, they detect the sequence in which determine whether the person is entering or exiting. If the sensor 1 is triggered before sensor 2, the system interprets that as an entry. If sensor 2 is triggered first, it considered as an exit. Every entry increases the counter by 1 and every exit decreases it by 1. The current count is shown on the 16x2 LCD display in real time. This provides a live overview of the number of people currently in the room. This system is very useful in many practical settings. For example, in classrooms, it can help keep track of student attendance without manual counting. In library reading rooms, it gives staffs an idea of how many people are present. Project rooms, it helps monitor occupancy. This system does not control any electrical or digital appliances. Its functions is limited to monitoring and displaying, which makes it safe, power efficient, and ideal for learning. This project is valuable for those studying embedded systems, automation principles, or basic digital logic. It combines both hardware and software aspects of engineering in a used in our project include the first one is Arduino Uno microcontroller, which processes the logic. The second one is two IR sensors for movement detection, and the third one is 16x2 LCD display to show the live count. The fourth one is the potentiometer to control the contrast of the LCD display, and other things like a basic electronic components, which is a breadboard, jumper wires, and the power main component, which is a sensor that we use here is an IR sensor. The IR sensors are passive and safe. They don't emit any harmful signals. They simply detect when something interrupts the infrared beam. It uses flags and timing logic to ensure that false counts are avoided. For example, when someone stands between the sensors or moves too quickly. Another good thing about our project is that it works entirely offline. It doesn't rely on Wi Fi, cloud, or any external services. This makes it reliable even in areas where internet access is limited or not available. It is also highly customizable. You can increase the number of sensors used or add a buzzer for alerts or even interface it with data logging modules if you want to track counts over time. But in its most basic form, it already serves a very clear purpose, providing accurate real-time occupancy monitoring using a component which we use is the Arduino Uno microcontroller. It acts as the brain of the system. It receives inputs from the IR sensors, process the logic to determine whether someone is entering or exiting, and updates the display. About Arduino is how beginner friendly it is. You can write the code download in the Arduino IDE a simple software platform, upload it using a USB cable, and immediately see the result. It does not require any external programmer or counting system. It's not just a controller, it acts as the entire decision making unit that connects sensing, processing, and output in one loop. This kind of microcontroller is ideal for counting, timing, automation control, and basic data handling, making it perfect to fit for student level.
Now I will be explaining you guys how to give connection. To make the connection easier to visualize, I have created a simulation using Oakview, an online simulator which helps demonstrate how the project works. However, since Oakview currently does not support IR sensor, we have used PIR motion sensor in the simulation for the demonstration process. So here is how the project works. The PIR sensor at the entrance is connected to the digital pin D2 of the Arduino. Similarly, the PIR sensor at the exit is connected to the digital pin D3. Now we will be looking at the connection of the LCD with the Arduino. The LCD has two pins, which is SCL and the SDA. The SDA of the LCD is connected to A4 of the analog pin of the Arduino. The SCL pin is connected to A5. So this is the connections we have done. These are the simplest connection. Now let's run the simulation. The LCD displays the in and the out count and the number of people who are currently inside the hall. So when the entrance sensor is simulated with the motion,
Let's see the working. The bidirectional counter using Arduino and IR sensors successfully detects and counts the number of people entering and exiting a particular area. It effectively distinguishes between entry and exit movements based on the sequence in which the two IR sensors are triggered. When the first sensor placed at the entry site is triggered before the second, the counter increments, indicating a person has entered. When the second sensor, which is placed at the exit site, is triggered before the first, the counter decrements, indicating a person has exited. This mechanism ensures bidirectional detection, allowing for a real-time count of people inside a space. We have a LCD display which displays the current occupancy count. The count updates instantaneously as a person moves past the sensors, providing immediate visual feedback. The display is clear and easy to read, making it suitable for both indoor and outdoor environments. This bidirectional counting system has a wide range of applications. Number 1. Visitor Management System. In building, offices, or malls, this system can track the number of visitors or employees entering and exiting a building. It helps in managing crowd flow and ensures safety in public spaces. Number 2. Retail stores. Retailers can use this system to monitor foot traffic, analyze peak hours, and improve customer service by making data-driven decisions such as adjusting staff availability based on foot traffic. Number 3. Security systems. In restricted or secure areas, the system can help track the movement of personnel in and out, ensuring that only authorized individuals are accessing specific areas. It can also trigger alerts if unexpected exits or entries occur. Number 4. Smart building automation. This system can be integrated with other building automation systems like lighting or security to automatically adjust based on occupancy levels. For example, lights could automatically turn on when a person enters the room and off when they leave. Number 5. Event venues and stadiums. For large events or stadiums, this counting system can help in monitoring crowd size, ensuring that venues do not exceed maximum capacity and improving crowd control effects. Museums or libraries can use such a system to track the number of visitors, helping to regulate crowd sizes, optimize the space, and provide insights into visitor behavior.
The bidirectional counter system, developed using Arduino and IR sensor, has proven to be an effective solution for tracking human movement.
And that's the video. I hope you all enjoyed it and gained knowledge from it. Thank you.